Welcome to EDU World Space.
Let's consider the isoelectronic ions, chloride and potassium, CO- and K+. For A, which ion is smaller? The potassium ion is smaller than the chloride ion. This is because the effective nuclear charge is more on the potassium ion by the nucleus. So the attraction of the nucleus on the valence electrons is more. So the distance between them decreases. In the case of the chloride ion, an extra electron is added, to the valence shell, so the increased repulsion expands the electron cloud and increases the size. For part B, let's calculate the effective nuclear charge for these two ions. So let's start with the electron configuration of potassium. Potassium has an electron configuration of argon 4s1, and the potassium ion has an electron configuration just argon. So the Z effective is equal to the number of electrons minus the number of core electrons. So 19 minus 18, the effective nuclear charge is 1. For chlorine, the electron configuration of chlorine is neon 3s2, 3p5. For the chloride anion, its electron configuration is neon 3s2, 3p6. The effective nuclear charge is the number of electrons, which would be 17, which would be 18. The core there, so sorry, 17 minus 10 core electrons, Z minus S, 17 minus 10 is equal to the effective nuclear charge of 7. Now let's use Slater's method to calculate the effective nuclear charge. So for C, let's calculate the effective nuclear charge of the potassium ion. So the shielding constant is equal to 7 times 0.35 plus 8 times 0.85 plus 2 times 1, which is equal to 11.25. So the Z effective is equal to Z minus S, which is equal to 19 minus 11.25, which is equal to 7.75. And for Cl minus, shielding constant is equal to 7 times 0.35 plus 8 times 0.85 plus 2 times 1 is equal to 11.25. Z effective is equal to Z minus S. This is equal to 17 minus 11.25, and this is equal to 5.75. For part D, how are effective nuclear charge and ionic radius related? So for isoelectronic species, we're looking at Cl minus and K plus. The effective nuclear charge is inversely proportional to the ionic radius with an increase in effective nuclear charge the attraction on valence electrons increases, therefore decreasing the ionic radius.